This is Algebra 1, Lesson 8.1, Multiplication Properties of Exponents. Today we are using properties of exponents to multiply exponential expressions, and we're using those powers to model real-life problems, beginning on page 450 in the textbook. First off, starts with three properties of multiplication of exponents. The first one is the product of powers property. Notice it says let A and B be numbers and M and N be positive integers. Remember, positive integers means not negative. Integers means not fractions or decimals or anything like that. So you're looking at what we consider whole numbers. To multiply properties having the same base, add the exponent. So what you have to know is multiplication is paired with addition. On the next lesson, actually 2 lessons from now, we're going to talk about division properties of exponents. Division pairs with subtraction, multiplication pairs with addition. It's a pretty easy concept when you see it in action. So your first example, A, you read this right here when you look at this and you read it out loud, you read that as A to the M times A to the N. Notice that the bases are the same, A, and they have one exponent is M, the other one is N. You add M plus N because the bases are the same. The example with numbers instead of letters or variables says 3 squared times 3 to the 7th. Since 3 is the same as 3, you add 2 plus 7, which gives you 3 to the 9th power. It's a really easy concept again. The second property is called the power of a power property. Now this is where it gets slightly confusing for people. It's a pretty easy thing to keep separate, but this is the only mistake people make. They'll try to, in the first property, they'll try to multiply 2 and 7, for example, and get 3 to the 14th. That's wrong. Only when it's a power raised to a power. Had this right here said 3 squared to the 7th, notice that's not the same thing as what's in the example. That's what this next example is. A to the M to the nth. You read it just like that. A to the M to the N, or A to the M to the nth. That's when you multiply M times N. Notice the difference between the two. This one was when they were multiplying by each other, you add the exponents. This one, a power is raised to a power, you multiply the exponents. Again, 5 squared to the 4th power. Instead of adding 2 plus 6 this time, now you're going to multiply 2 times 4. I said 2 plus 6. I meant 2 plus 4. You're going to multiply 2 times 4 to get 5 to the 8th power. And then the last one kind of goes against, not really, but it kind of, you're comfortable with please excuse my dear Aunt Sally. And the example they show kind of goes against doing what's in parentheses first. It's not made for that, though. It's made for when they're actually different numbers, and I'll show you what that means in a minute. To find a power of a product, find the power of each factor and multiply. This is, again, this is an easy thing for people to understand because most of y'all are very good with the distributive property. It's not technically accurate, it's not technically correct to say to distribute this M to both of them. But most people can think of it that way and work through these problems with no problem. A times B to the M power, the fact that A and B are different actually helps out in this case. 2 times 3 to the 6th power. No, most of the time we would multiply 2 times 3 and get 6 to the 6th power. But if you had two things that you couldn't multiply, if that had said like 2 times x to the 6th power, then you would distribute 2 to the 6th power and 3 to the 6th power. Notice that's what you get. 2 to the 6th power times 3 to the 6th power. Again, distribute is not technically the correct term. It's okay if you think of it that way. But if you were to write that in front of somebody who's like a math professor or something, they might get upset with you. So think of it that way, but don't call it that. Example number 1 is using the product of powers property. So this is the most simple this is the most simple property in action. 4 to the 3rd times 4 to the 5th. Notice your bases are the same, 4 and 4. So do we add the exponents or do we multiply? This is when you add them because you're not raising a power to a power. So you're going to have 4 to the 3 plus 5, which is 4 to the 8th power. Looking over to the right, now you have variables. Y to the 4th times y to the 5th times y to the 6th. It doesn't matter how many terms you have. It doesn't have to just be 2. It can be 3. It can be an infinite amount of them. When they're the same base, y, and y, you add the exponents 4, 5, and 6 to get y to the 15th. The same thing's true with c. 6 squared times 6, what you have to understand about this one, and this is another mistake people will make, is they'll forget that there's an exponent right here. Okay, that's a very common thing to forget. There is an exponent there, 1. You don't ever have to write it, but when you're doing problems like this, it might help you to write it. Just like you never have to write the square root of 4, you never have to write the index 2 right there, and eventually we'll get to that, to where there's a different number besides 2 right there. Just like you never have to write anything over 1. You know everything's divided by 1. It's the same thing. But when you're doing a problem like 6 squared times 6, you have to remember that there's an exponent of 1 right there, which means 2 plus 1, which is, I'm sorry, 6 squared times 6 to the first power, which means 6 to the 2 plus 1, which is 6 to the third. And then the last one, negative 3 times negative 3 to the 7th. Again, both bases are negative 3. But just like C, you have to remember that there's a 1 right there. Negative 3 to the first power times negative 3 to the 7th power. Add 1 plus 7. So it's negative 3 to the 1 plus 7, which is negative 3 to the 8th power. Again, very simple concept. Let's practice that. You have an entire back sheet with nothing else on it. Take 20 seconds to do this one. Okay, 4 to the 5th times 4 to the 3rd. I'm not interested in the very last step, the part that is helpful to use calculators for. You just have to know that you're multiplying the same base, 4 and 4, so you're going to add 4 to the 5 plus 3, which is 4 to the 8th. This is as far as you have to go. If you went further than that, it's okay, but 4 to the 8th is good enough. I want you to know the algebra of it. There you go. Take 15 seconds and do that one. Y to the 3rd times y to the 4th times y to the 5th. Again, all the bases are the same, y, and y. Just like the example a minute ago, you add 3 plus 4 plus 5. 3 plus 4 is 7, and 7 plus 5 is y to the 12th. Most of the time, you're going to like doing variables with this kind of stuff way more than you're going to like doing problems like this, because there's always going to be that thought when you get to the end of this one, should I do 4 to the 8th and get that big number? Or when you have variables, you don't have to worry about that. You know, as far as you can go is y to the 12th. Okay, take about 15 more seconds on that one. Okay, you got 2 times 2 to the 6th. Again, same basis, 2 and 2. Don't forget that in that first one, both of them are the same. In that first one, there's an exponent of 1. Again, it's just like the examples a minute ago. That's 2 to the 1 plus 6, which is 2 to the 7th. And then let's do this last one for me real quick. Take about 15 seconds. You got negative 5 times negative 5 to the 3rd. Again, what you have to see is that bases are the same. They're both negative 5. You have to not forget that there's a 1 exponent not shown on that first one. So it's negative 5 like this to the 1 plus 3, which is negative 5 to the 4th. It matters that there's a parentheses there. So if you didn't put it, go ahead and put it now. Negative 5 to the 4th power. Example number 2 is using the power of a power property. Now we just practiced 4 different versions of the same property, adding the exponents. Here are 4 different problems where you're actually going to multiply the exponents. Note the difference with A. Notice the difference with A. 7 to the 3rd to the 5th. It's a power to a power. This is when you multiply 3 times 5 to get 7 to the 15th. Again, variables are easier for most people. On B, it says x squared to the 5th or x to the 2nd to the 5th. Instead of adding 2 plus 5, you multiply them here. You get x to the 10th power. Now for C, it says negative 2 to the fourth to the third. Don't let the brackets and everything confuse you. You're going to do it the same way. It's still a power 4 to a power 3. So you multiply 4 times 3. So it's negative 2 to the 4 times 3, which is 12. And then the last one says b minus 1 to the 6th power to the 4th power. You're going to make sure you give the 6th power to both of them. Okay. B minus 1 to the 6 times 4. Oh, we'll get to that on the last example. But it's the 6th power raised to the 4th power. You're going to multiply 6 times 4 and get b minus 1 to the 24th power. Again, notice the difference between all the example 1 problems and these problems. These are powers to powers, not same bases multiplied by each other where you add the exponents. We're going to have 4 practice problems with these. 5 squared to the 3rd power. Take 10 seconds on that one. Okay, 5 squared to the 3rd power. You do not add the exponents here, 5 to the 2 plus 3, because you're raising a power to a power. It's going to be 5 to the 2 times 3, which is 5 to the 6th power. Again, that's as far as you're going to have to go. X to the 3rd to the 2nd power, or x cubed squared. Take about 10 seconds on that one. Again, notice with this one, variables seem a little bit easier than 5 squared to the 3rd. You're going to do them the same way, though. It'll be x to the 3 times 2. We're not adding them this time because you're raising a power to a power. So you're going to get x to the 6th power. Do this one. Negative 2 to the 3rd to the 4th. Again, a power to a power. So you're going to have negative 2 to the 3 times 4. You're going to do it like that, which is going to be negative 2. 3 times 4 is 12th power. And then try this last one, a minus 2 cubed squared. Again, we don't know what a is, so we can't subtract a minus 2, but what we can do is a minus 2, just like the example, to the 3 times 2. Remember, when you raise a power to a power, you multiply 3 times 2, you don't add them. So what you get is a minus 2 to the 6th power. That's all we can do with that. Now we're going to look at an example in a couple of minutes where we'll go a little bit further than that, but let's take a look at example number 3 now. Now it says using the power of a product property. Now you have 2 times 3 to the 3rd power. Okay. We know, again, and this kind of goes against this first example, A, goes against our order of operations, which tells us to do parentheses first. We look at that and we say, okay, well, 2 times 3, I know I got to do 6 and get 6 to the 3rd. But if you look at B, it says 9xy. You can't combine those to get something like the number 6. So if you have a situation like that, you do like the distributive property right there. It gives you 2 to the 3rd times 3 to the 3rd. 2 to the 3rd is 8. 3 to the 3rd is 27. And when you multiply 8 and 27, you're going to get 216. For B, it's going to say 9xy squared. You're going to make sure that all 3 of those things, it's only one term, but it's 3 things inside there. You're going to make sure all 3 of them get squared. So it's going to be 9 squared, x squared, and y squared. Okay, that means 9 times x times y, which means 9 squared times x squared times y squared. Now 9 squared is easy, it's 81. You can't do anything but write x squared and y squared. That's the simplified version. Negative 3x to the 4th power, you're going to do the same thing. You're going to make sure negative 3 gets to the 4th power and z, I said x, negative 3 and z get the 4th power. So negative 3 to the 4th power times z to the 4th power. So notice what it says at the beginning. It says to identify factors. So it just is, which I call them things when you're looking at it, because it's only one term, but it's factors, negative 3 and z. and then make sure both of them get raised to the fourth power. Negative 3 to the fourth power is negative 3 times negative 3 four times, which gives you a positive 81. We know that because it's an even amount of an exponent. Positive 81 z to the fourth power. And then D says negative 4w to the third. You're going to make sure you're going to make sure to identify the factors again. It'll be negative and then 4 times w to the third. Then you're going to make sure to give the third power to both things. So it's negative 4 to the third times w to the third. And that's the second step, is raising each factor to a power. Then simplifying 4 to the third. We know 4 times 4 is 16 times 4 is 64. It doesn't matter if this is positive or negative right here. Or does, but it's going to become negative when you have that negative 1 that's out front that you're going to multiply by, that negative 1. So negative 64w to the third power for that one. And then let's take a look at a few examples to make this make sense too. Okay, 3 times 4 to the second power. Don't multiply 3 times 4 first. Okay, you have 3 times 4 squared. Make sure both things get squared. So that's 3 squared times 4 squared. 3 squared we know is 9. 4 squared is 16. And 9 times 6 is 54. 9 times 1 plus 5 is going to be 144. So 144. The second one, 3xy to the fourth. Take about 15 seconds on that one. Again, if you have to separate this is not a necessary step, but if you have to separate it to make it do this, to where you can see it, it's okay. Just make sure once you do that, that you give the fourth power to all three things. 3 to the fourth power, x to the fourth power, y to the fourth power. 3 times 3 is 9, times 3 is 27, times 3 more we know is 81, x to the fourth, y to the fourth. Negative 3y squared. Again, it's just like example C from a second ago. We have negative 3y squared. Again, if you have to separate them, do so. Negative 3 times, might even be easier to add this right here. Negative 3 times y, and then all of that's being squared. It's not necessary to write that step, but if you have to see it, it might help you. Negative 3 gets squared, and y gets squared. Negative 3 squared means negative 3 times negative, and negative times a negative is a positive. 3 times 3 is 9y squared for that one. And then the last one, negative, notice the difference between C and D, 3y squared. Okay, and then the difference again between C and D is the negatives outside of the parentheses. So it acts like negative, then 3 times y squared. The square goes to both of them. The negative is still there. 3 squared, y squared. 3 squared is 9y squared, and then that negative comes down right in front of it to make it negative 9y squared. And then example number 4 is putting them all together using all three properties. It says simplify 7w squared z to the third power, z cubed, squared times z to the fourth power. So we're going to put everything together on this one. First thing is the power of a product. So for this first one, you're looking at just this part of it. You're raising everything inside of that parentheses to this exponent that's outside, 2 squared. So you're given 7 squared, you're given w squared squared, and you're given z to the third squared. So notice 7 is getting raised to the second power, w squared squared is being raised to the second power, and z to the third is being squared. Then the last part is times z to the fourth. Notice that's just written on the end. That's not getting squared. Don't square that. So 7 squared we know is going to be 49. W squared squared, or w to the second is going to be w to the 2 times 2, which is w to the fourth. Z to the third to the second is z to the 3 times 2 again. It's not fifth. It's not plus. It's z to the sixth. And then z to the fourth just comes down. Now the next step is multiplying the same bases. Now you have z to the sixth and z to the fourth. Those are the same bases, z and z. So now instead of multiplying 6 times 4, and this is the only part that gets confusing with this, instead of multiplying it, now you got to know you're not raising a power to a power. Now you're adding 6 plus 4 to get z to the 10th right there. So 49, w to the fourth, z to the 10th. And then we have one more example to look at. Simplify 3x to the fourth y squared times y to the fifth. Take about 30 seconds on this one. All right, let's take a look at it. We have 3x to the fourth y squared. So you might want to take this and separate it to where you can see everything. The factors of this are 3 times x to the fourth times y. Again, that's not a necessary step for everybody. If you can see it without having to do that, that's fine. Then make sure everything gets squared. That gets squared, this gets squared, and this gets squared. The easiest thing to make a mistake on, and the thing that I see people make mistakes with the most on this, is they'll square 3 and they'll square x to the fourth and they'll leave out y. Or they'll do 3 and they'll do y and they'll leave out x to the fourth. So they'll do some of them but not all of them. So what that means is 3 gets squared, x to the fourth gets squared, which means x to the fourth times 2, not plus. And then y gets squared. And then you bring this part down, times y to the fifth. So simplify it. 4 times 2 we know is going to give us x to the eighth. And 3 squared is going to be 3 times 3, which is 9. So we have 9 times x to the eighth times y squared times y to the fifth. And then the last step, you notice that y is the same base. So the only thing you do with that is y to the 2 plus 5. So that's going to be y to the seventh. We bring the rest of it down, it'll say 9, and then it'll say x to the eighth, y to the seventh. That is your simplified version. And then here's your checkpoints. Negative 4 to the third times negative 4 to the sixth. Same basis. Both of them are negative 4. So you're not raising powers to powers here. They're the same basis, negative 4. You add the exponents, 3 plus 6. Negative 4 to the ninth power. W to the 10th times W. And notice it doesn't say an exponent right there. You have to remember there is an exponent right there of 1. So that's w to the 10 plus 1, which is w to the 11th power. D to the fourth to the fifth. Notice now, unlike number 1 and 2, now it's a power being raised to a power. So now you multiply 4 times 5. You don't add them. D to the 20th power for that one. Number 4 says 6p squared. You have 2 factors. If you have to separate them to see them, do that. Not a necessary step, but do it to where you can see it. 6 gets squared, and p gets squared. 6 squared, we know it's 36. P squared. Negative 2xy to the fourth. Negative 2, separate them if you have to. Negative 2 times x times y, all that's being raised to the fourth power. So negative 2 to the fourth, x to the fourth, y to the fourth. Negative 2 to the fourth, x to the fourth, y to the fourth. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. X to the fourth, y to the fourth. And then the last one, you're putting it all together. 2wz squared to the fifth times wz squared. So you're going to do this one. You're going to make sure 2 is separate from w is separate from z, and it's being squared. So make sure everything gets squared. So 2 squared w squared z. You might have to draw this to where you know the difference between 2's and z's squared. I'm sorry, I made a mistake. The only thing that's squared is z squared. Everything's being raised to the fifth power. So 2 to the fifth power, w to the fifth power, z to the 2 times 5. So 2 to the fifth is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. W to the fifth, z to the 10th. That's that part. The other part, you're making sure I was looking at this when I was saying squared a second ago, is w squared, z squared. So times w squared, z squared. Now put your like bases together. W to the fifth and w squared will be w to the 5 plus 2. And z to the 10th times z squared is z to the 10 plus 2. So we have 32 w to the 7th, not to the z, w to the 7th, z to the 12th power.